Hi, I'm State Representative Seth Grove, and welcome to another edition of Legislative Report. Today we're at Magnesita Refractories, which is also known as J.E. Baker in a past life, and with us is Justin Buck, Vice President of Operations. Thank you so much for having us.
Representative Grove, thank you for being here today.
No problem. Excited to be here. We'll get to see some cool stuff. Obviously, there's a quarry on site, the business end of final product making. But before we get to that, can you tell us a little bit about Magnesita, the company in itself, and its history here with York County?
Okay. The company as it exists here on this site started about 125 years ago as the Baker Company, as you mentioned before. Started just east of here. The Baker family moved the operations by investing in a number of quarries and reserves here in York County around the turn of the century. Landed on this site in 1950 for its high purity dolomite reserves that you'll see here in a few minutes. After several years of mining the stone and burning it to produce a key product for the steel industry, they built the refractory manufacturing plants. Built the brick plant in 1964, the first monolithics plant in 1977, a precast plant in 97, and more recently we've expanded again and added another alumina monolithics plant in 2012. The Baker Company was purchased through acquisition and eventually became Magnesita Refractories in 2008, a part of a much larger company. Magnesita itself originated in Brazil about 100 years ago. Now, as a global company, we have operations on 4 continents, over 6,000 companies globally. And this is Magnesita's North American refractory manufacturing operation, serving the North American markets as well as some key markets in the Far East as well.
Wow, that's a huge footprint, just based here in York County. How many employees do you currently have here?
We currently have about 370 employees working here on the plant site. In total, we have about 480 employees in York County and some of the surrounding counties as well, and a total of about 600 employees throughout the United States, including our commercial salespeople and technical support staff.
That's a great footprint. Obviously, part of your mining operations is dolomite, which I think we'll get into a little bit later. You take that and then you do some manufacturing. How many career jobs are ready? So if I'm a high school graduate, can you come right into work for Magnesita?
Absolutely. We're looking for high school degreed applicants, preferably with some work experience, some heavy industrial work experience. We have a wide variety of operations here. A very diverse operation from heavy manufacturing that you see in the quarry, running loaders and haul trucks, some manual type work, to in the brick plant, you'll see a heavily automated process, so requiring some very strong troubleshooting skills, even on the operational side. We're always looking for strong leadership skills as well. We're often looking for operators to come and start working for us in the brick plant, also in the maintenance trade as well. That's a key area for us, bringing in skilled maintenance folks. We have some work that requires heavy mechanical skills such as welding, electrical, but also work in pneumatics, hydraulics, automation. So again, the high tech technology that we have here.
And there's always seems to be a job opening within the career and tech field. Whether I know we constantly have needs for welding, but other maintenance. Where would you go for that kind of skill level? Vocational school, York Technical Institute, HAC. Those are the directions you kind of want to go in to get these kind of jobs?
That's right. So we're looking for candidates who have come up through the York County Votech, Thaddeus Stevens, some of these other technical schools, and develop those skills through those schools, and also through working for other companies.
Yeah.
To be honest, we're looking for that industrial experience.
Wow,
well.
That's great. With that, let's go check out, I believe, the quarry. I'm going to go see some blasting and talk to one of your local geologists, and then we'll head over to the refractories and see the brick making process.
Terrific.
Great. Now that was explosive. obviously we're at a quarry, and Liz, you're head geologist here, so you know everything about this quarry and why they just did some blasting here. So obviously dolomite's important, and why is Magnesita here? Why is dolomite important? And why did we just do some blasting?
All right, well, you're right. Dolomite is very important. We are here at Magnesita's York Quarry, and we've actually been mining here continuously since 1950. This is a world-class dolomite deposit. We are located here in York County on 1,500 acres, 575 of which is actually permitted for mining. Here in the main pit, we have like I said, a very high quality dolomite.
And what is dolomite?
Now, okay, dolomite is a rock type. It's very similar to limestone, which many people are familiar with, except that it is magnesium carbonate instead of calcium carbonate. And our stone has unique properties, both physical and chemical, that allow us to send it through our 2 rotary kilns and turn it into a refractory material. Now, the dolomite, the chemical properties that make it good for refractories are the very low impurities.
And how did dolomite get here? Like, take us back in time to how dolomite formed right here in West Manchester Township.
Okay, so if we go back to a time in Earth history called the Cambrian, and this is about 500 million years ago.
Wow.
Yeah. This area would have actually been very similar to the Bahamas.
Wow. So palm trees, beachfront
yes,
property.
Yes, we could have been knee-high in crystal clear water.
Wow.
It would have been really nice,
yeah.
actually. And so in these warm, shallow seas, there was a lot of calcium carbonate. And as you get more and more calcium carbonate in the water, it ends up precipitating out. And so it'll fall out of the ocean, and it will form a limestone.
Okay.
That's the rock that it will form. And so whenever you have an environment where there's a lot of wave action, like again, you're in the Bahamas and there are waves crashing, it will actually take this calcium carbonate and it will form little spheres. And through time, after everything has been deposited on the seafloor, eventually we had some high magnesium brines and fluids come through the rock, and it actually replaces the calcium in the calcium carbonate with magnesium. So whenever this formed, this is a very pure limestone. And since the magnesium switched out, it ended up being a very pure dolomite.
Wow. So 500 million years ago, we're Caribbean Sea. At some point, that dried up. Glaciers came down.
Much later,
much
yes.
Much later.
Yep.
Probably deposited a lot of sediment, earth on top of it, and now it was obviously rediscovered over 50 years ago, and it's been continual mining here since then.
Exactly.
Wow.
Yep. It's quite the story.
Yeah. All right, so we saw the mining operations, the quarry. From the quarry, all that stone gets crushed, brought up here, and then it's refined down through a kiln process. So can you kind of just walk us through?
Absolutely. As you saw, we have the dolomite quarry right here on site. It is very, very unique in that it is the highest dolomite in the world for making refractory products, and the only one in the United States doing this. And very unique in that the quarry is integrated with the entire plant for processing the stone and making the refractory products.
And literally, in the entire world, there's no better quality dolomite than right here.
That's correct.
Wow.
It's very special, and it's very low impurity levels, and it's high density, which is very critical for making a refractory product that will withstand the high temperatures of the steel making and cement and lime and other processes that it is used in. So after it is mined out of the quarry, it's crushed down to about a 2.5-inch size, crushed again to about a 1/4-inch size, and the fines are screened to this feed size that you see here. This size feed is introduced to the kilns, It spends about 6 to 8 hours in the kilns, reaching a peak temperature of about 3,500 degrees Fahrenheit. So very, very hot, the hottest running rotary kilns in the world. And that hot temperature is required to drive off the CO2 that's inherent in the stone, and to create that dense dolomite sinter that we talked about. And when that sinter comes out of the kiln, it's at a temperature of about 3,000 degrees Fahrenheit. It is then cooled and placed into bins, where it is later processed more and used to make the refractory products that we'll see in a little bit.
Wow, you can just see the dark brown color of that. Now, is there any residual waste from the kiln process that gets reproduced in anything else?
There's a byproduct that's generated through our crushing and screening process.
Okay.
It's an agricultural lime product that is it's processed further and sold for local agricultural applications. We sell about 300,000 tons per year to different agricultural industries, like for use in cattle bedding, as a soil conditioner to raise the pH level of the soil, in farming applications, also a pelletized lime that we make for lawn and garden applications. We even have an agricultural product that goes into the production of kitty litter. So very unique in that this byproduct stone is used for other applications
Yeah, have you
as well.
talked to Arm & Hammer and all about their kitty litter line?
Absolutely,
Yeah.
we're always talking
Yeah,
to
super great,
potential
you're a
new customers. Yep.
That's great.
And this process for producing the dolomitic sinter to get a high temperature like that, it does require very intense heat. We use a very specialized coal and petroleum coke fuel that is essential for getting that high temperature. We need the ash that is in that coal and the intense flame that's produced from the coal to generate the very dense sinter that's required to make our products that go out to the stainless steel applications, the carbon steel manufacturers, to make the steel products that are used throughout the United States.
Yeah. Now, when you say coal, that triggers worry, because there's a lot of federal regulations coming down. Obviously, Pennsylvania is well known as a coal state. We have probably over 300 years of supply of coal underneath Pennsylvania. Does that worry you about federal regulations coming down and the effects of coal and the emissions and so forth?
The new regulations are always of concern. It's something we're always keeping our eyes on. We are currently under very strict environmental limits. We've invested about $5 million in the past 15 years or so to improve our environmental compliance, improve the efficiency of our processes. So we continue to make that investment over time. We remain well within our regulatory limits. They are becoming potentially more and more stringent as we go through time. And we're right now researching the technology that might be required to reach the new limits, evaluating whether it's technically and economically feasible to continue to make the raw material that we need, that is critical to making our end products.
Yeah, and there's always a cause and effect. Obviously, everybody wants a cleaner, better environment, but there's always a cost attached to that, and a lot of times implementation becomes a heartache for the end user, the business end. And obviously, when you have the amount of jobs, great jobs, family-sustaining jobs that this business creates, the goal isn't to drive you away from Pennsylvania, away from the United States, into other areas. Like, we want to keep you right here, operating, keeping people employed, and having health insurance and making great wages.
Absolutely.
It just gives right back to the economy.
Absolutely, and we're a great example of how we can do that. At the same time, you look around our plant, look at our stack, and it is the emissions are very clean. And it's a good example of balancing both.
So we kind of went through the kiln. Let's go and check out the brick making facilities and see how you do that with, I believe, a lot of robotics.
Absolutely.
Yeah, great. So here we are with your specialty product line. So what are we looking at and how you do it?
Okay, so we're looking at some of the products that we make from that dolomite sinter raw material that you saw. This is a precast ladle bottom that's used to line the bottom of a steel ladle. It's a very quick, or much quicker installation for the steel customers. Saves them time, saves the ergonomics, saves the backs of their employees. It's a very drop-in solution for something that used to take much longer to brick in the bottom of a ladle in the past. To go along with this,
how much heat does that have to be able to take?
Around at least 3,000 degrees.
Wow. Okay.
So a very hot application. To go with this precast ladle bottom, we also make some specialized shapes that fit into these holes that you see here. So well blocks and stir plugs that are essential in the steel heat treating process, and flow control in removing the steel from the ladle, getting it to a caster to make the steel products. And then along here, this is another style of ladle bottom. This is a glued, assembled bottom that's made from the bricks that we produce at our brick plant that we'll see in a few minutes. Another kind of variation on that cast ladle bottom solution. And then you see these bags here. These are granular monolithic products that we make here, also out of the dolomite sinter raw material. They're bag materials that are used to fill in these openings. So the well blocks and stir blocks fit in the holes that you see here.
Yep.
These materials are then rammed into place around to fill in the gaps of that application. From there, the customer will install bricks along the walls of the vessel and have an entire ladle lined with Magnesita products.
Wow.
Okay.
Now this is glue material. What's the temperature before that breaks down? I guess once it's in, it doesn't really matter if it breaks down anymore, right?
That's right. The thing that matters is the cold strength to get it into its application.
Okay.
This after it's glued, this bottom will set for 24 hours to give that epoxy enough time to air set. It's then packaged and delivered to the customer as you see it here.
Okay.
Okay. So that said, we'll move along and see how the bricks are manufactured in that part of the plant.
Did you know that the state capitol is not only the epicenter of the Commonwealth's governing bodies, but was once home to 390 preserved Civil War flags? During the war, it was customary for each state to furnish their regiments in battle with flags representing their contribution to the Union Army. After the war, Pennsylvania's military department was responsible for collecting the flags, and in 1872, they were reverently housed in the Capitol. Following the completion of construction on the new Capitol building in 1914, the Civil War flags were moved to the Capitol Rotunda. They were kept untouched in custom-made flag cases until 1982, when the Capitol Preservation Committee initiated its Save the Flags project. Throughout the years, dust and long-term vertical display of the flags had begun to devastate the brittle silk fabric and painted designs. The flags were removed by local textile conservators and were repaired and preserved in storage units that protect the relics from light, dust, and excessive handling. Now you know.
All right, so here we are in the brick manufacturing. We have some awesome new technology behind us. Kind of explain what's going on in your products.
Okay, so the sintered dolomite, as well as sintered magnesia that we bring in from our sister plant in Brazil, and some other additives are mixed together with an oil-based binder, pressed into these brick shapes by the presses that you see behind us. We have 9 presses. The bricks are pressed at pressures up to 2,000 tons, so very high pressure pressing. They're stacked on kiln cars and racks by the robotics that you see behind us, and fired in tunnel kilns and an oven. This family of bricks here, these are fired dolomite bricks. These bricks are used in steel AOD vessels for making stainless steel. This brick is used in a rotary kiln similar to the ones that you saw in operation here. These bricks are fired close to 3,000 degrees Fahrenheit, then cooled and carefully inspected by our quality control group and our operators. The tolerances are checked and then packaged into plastic packaging as a finished product, shipped out the door on trucks and by rail car. This family of bricks that you see here, this is a tempered dolomite brick and a tempered mag carbon brick. This brick would be used in a steel making electric arc furnace. This one to line a steel ladle. So you saw the pre-glued and pre-cast ladle bottoms in the other plant. These bricks here would be used to line the walls of that vessel. These bricks, after they are pressed, they're cured in an oven at a lower temperature of only 500 degrees. Different process different binder system, so they're getting that low temperature bonding, and then the full ceramic bond takes place once they're in the full up to full temperature in the customer's application.
Gotcha.
Okay. We've, as you can see here, we've invested in a lot of technology over the years.
Yeah.
This plant, Magnesita, invests about $10 million per year in CapEx towards improvement projects, capacity increases, and just overall equipment replacement projects. In addition to that annual spend, they have invested in capacity increases in recent years. We added a press here in 2012, added a monolithics plant in 2012 as well, about a $7 or $8 million investment, increasing our capacity by about 10% at that time. Since the end of 2010, we've actually increased our workforce by about 20% over that time as the market in the U.S. has grown, as the economy has improved from the recession. As Magnesita has gone after increased market share, and as we have expanded our capacity here, so a lot of growth to the plant here that really helps to feed the local economy.
Absolutely. I'm sure there's outside supply chains that reinvest locally right here by Magnesita through the normal supply chain process as well. So
that's right.
Every great large manufacturer just competes on supplying jobs throughout the entire economy here in York County. So it's great.
And some of the other key investments too, we are really putting a lot of effort into investing in the safety of our employees. Magnesita invests about $1.5 million per year in safety improvement projects to improve the ergonomics, to reduce injuries. We're really trying to increase our awareness and our efforts to improve the safety of the workforce, as well as to improve to invest in training of the employees, technical training for our maintenance folks. There's a lot of high-tech jobs here, as you see, and that doesn't require that training that we're really trying to improve and increase here at Magnesita.
Yeah, and you were telling me you partnered with the York County School of Technology to do some additional electronics trainings?
That's right. We brought them on site. They're currently training a group of 7 of our electrical employees in some of the basic electrical theory and circuits and things like that. So a combination of classroom theory and hands-on circuit board training and in the plant applications as well. So a great program that we're working with that group on.
That's great. Well, I appreciate everything. Appreciate the tour.
Thank you for coming to see us.
Thank you for everything you do, providing jobs in our local community.
Thank you.
So here we are with one of the employees at Magnesita, Dustin Sterner. Ironically, we also graduated high school together at Spring Grove. Great story on getting a job outside of college. I know most parents want to see their kids go to college, get a 4-year degree. What's interesting is a lot of 4-year degree students are going back to career and tech, what you already have done, with hundreds of thousands of dollars in student loan debt, when they could have skipped it and just basically came in and did exactly what you did. Now, behind us we have a press. You're a mechanical coordinator, so your job is to keep all this stuff operational, functioning. So you're kind of a jack of all trades?
That's correct. Yes, we do electrical, mechanical. Obviously, this press is all driven by hydraulics, controlled by a PLC, programmable logical controller, and we have robots that take the brick and stack them onto the kiln cars for the firing.
So, in order for you to come here, what was your career path to get you here at Magnesita?
I actually graduated from York County School of Technology in '98 and was an electrician by trade. Worked 13 years at a local contractor in an industrial setting. Came here in 2012 and started as a multi-craft and just kind of worked my way up here to the role that I'm in now.
Excellent.
Yeah.
Your schooling at the York School of Technology, was it valuable to get you here? Life skills, family sustaining job?
Absolutely, yeah. It gave me the skills I need, the basic skills I needed to get in the door at places like this and continue my career here.
That's great. Are you going to seek any further education? Have you gone to different classes to continue to advance and understand new technology coming out?
Absolutely. Magnesita sent me out to Detroit, to ABB University, 3 different times to learn these robots. We did programming, troubleshooting, electrical maintenance on them out there. We also go to a Rexroth school, which is one of our suppliers of our hydraulic components. And we go out there and go through some troubleshooting techniques and other setup techniques as well.
Wow. When someone gets into here,
how much time does it take for someone to understand these specific machines? Are most robotics working the same thing with presses? Like once you dealt with the press, you generally know how it operates?
Yeah, basically all of our cells are pretty much the same. They all have their little intricacies, but they're all basically the same, and they all have their little niches too, so you kind of know what this one's doing when, and
Yeah.
you hear it, it sounds different, you know what's going on. So they're unique in their own, but they're also a lot alike.
Wow. If you could talk to someone in high school today, elementary school, middle school, what would you tell them about the career and technical fields, like what you're doing here today? What's the benefits of, instead of maybe looking at just the 4-year, doing
Right.
something that you're doing today?
Well, I definitely think it's for the mechanically minded individual, you know. Someone that's maybe not so much into reading the books or whatever, but like
Yeah.
getting their hands dirty, like tinkering things, you know, maybe take a lot of toys apart as they were
Yeah.
a kid, that kind of thing, you know, likes to fix stuff, likes to take pride in their work and, you know, see something come out of the ground and manufactured into something, or when you walk away from a press and fix it and it's running, you know, everyone gives you a pat on the back and
Yeah.
say, you know, it's a very fulfilling feeling.
Yeah, that's great.
Yeah.
Dustin, thank you so much for
You're
what you
welcome.
do. Appreciate someone taking an interest in career and tech, and I think you've highlighted the need
Yeah,
for obviously
absolutely.
these jobs. And,
There is,
and,
yep. We so often struggle to find employees here in the maintenance department. So we're looking for technically minded individuals, definitely.
Wow, that's
Yep.
great. So
Okay.
thanks once again.
All right, thank you.
Yeah. That's all the time we have today for Legislative Report. Again, I'm State Representative Seth Grove. If you have any questions on anything you've seen here today in today's show, contact information will be provided at the end. Thanks again, and we'll see you next time during Legislative Report.